Hi there, this is Year 12 Discrete Maths for OCR Further Maths. I say OCR, it can also be used for Edexcel as well, this particular topic. But definitely not AQA, and I'm going to talk about that a bit more in a moment. You'll notice I've got this critical path analysis topic, and there are two methods essentially. One is activity on the vertex, and one is activity on the arc. And this is most definitely not the AQA version, this is the OCR and Edexcel version. Where the activity, and you can see here I've got a number of activities A, B, C, D, that can take place at a variety of times. And as with all these questions, your job is to try to draw an activity network which maps out the best way of planning this course of activities so that you effectively finish them all within the shortest amount of time, or it might be the shortest amount of cost or something like this. This is a topic, critical path analysis. It's used extensively in the building industry, for instance, and it's a very important topic. And there are two methods for doing it, and we, as I say, are using activity on the arc. So, for instance, I don't know what A is. It could be we're going to paint a bedroom. The very first step might be to take the wallpaper off the walls. At the same time, I might be able to get someone to choose the paint. That might take some time as well to go out and buy the paint. I might need to prepare the woodwork. And you can see a number of different activities could all come together so that eventually, by the time I get over to here, this end node, this end vertex, I might have finished the activity. How we get there is a variety of different ways of doing so, I suppose, and we're trying to do it as efficiently as possible. So this is the OCR specification. It says very clearly we need to be able to construct and interpret activity networks using activity on the arc. So this is the bit that says OCR is different from AQA. The same as Edexcel, but definitely different from AQA. So if you see some questions like the AQA ones, ignore them. Now, notice the way this is being set up. You have this activity, and you go from 1 to 2, and to get from point 1 to point 2, this, I mean, 1 and 2 really aren't, they don't really mean anything. It's just a way to join up the activities. It's almost like the gap in between them. But this one might take 5 days to complete, for instance, 5 hours, 5 minutes. I don't know what it is. It might cost £500. So you can see it can be used in a different variety of different ways. And what you'll notice is these dummy activities as well, and we'll come across those bit by bit and more as we go through this. And so these dotted lined activities, they aren't real activities, but for the sake of the activity network, we need to show them, and we definitely need them for the exam. I think this was an exam question from OCR that I've taken the activity network from. So just to highlight this, one time when we might need to use that is it comes about because we're not allowed to have two activities start and end at the same node or vertex. So here you'll see I've got an activity A going from 1 to 2, but I've also got a different activity B. Now, A might take, I don't know, what we had just now, we had a 5 there. Let's make this up 3. There, 3. So you can see these aren't the same activities and they take different amount of times to complete. Now, the way we get around that is we have our A going to 2 and we have a B going, and this is one way of showing it. I suppose I could do it in a slightly different way, but broadly that is what what we would do. So it seems a bit odd, but that is a rule that we must have. And be aware of that. We're not allowed this two activities coming into the same vertex from the same vertex. If you like, 1 to 2, 1 to 2. No, we can't have that. 1 goes to 2. And it seems a bit odd and a bit weird, what a made up rule. And just you have to run with it. That's what you're expected to do. So we'll see some examples here. I've got some activity networks we're going to complete. And we'll see how we get on with them. So I've got them loaded up already, and this table then shows the task involved in, I don't know what it is, it could be painting this bedroom that I made up before, it could be something completely different, but you'll notice task A, it takes 3 hours, and we have what are called immediate predecessors. Now, immediate predecessors are jobs that you need to complete before you can start it. Now, the good news is on this particular job, we can get on with A, B, and C straight away. We don't need to worry about those. But you can see that D, I can't do D until I've already done A. It needs to be completely done before I can do A, and that will, well, effectively, you can see I can start D, which will take 5 hours, but I can't do it until after A has started. So we have these kind of rules that we've got to have to abide by. And we'll see those bit by bit as we go through. So here I have it. So it says activity network, example 1, and I've drawn up here the fact that we have got A, which takes 3 hours. So we're going to need a start node, and there it is. Now, sometimes you put a dot, and that's it, or you put a 1 in it, just to say it's the first one. Sometimes you put this, like double box, and I'll show you why the double box is useful in a bit. But I'm going to use a double box for each of my nodes. And you'll notice A comes off it, which is 3 long. So and B comes off it, which is 4 long, and C comes off it, which is 6 long. So I can draw those any way I like. So there you go, A, B, and C done. And you get the general form of this is you write your activity, you put the length of the activity in brackets, and you put an arrow to show which way you're going down this. So you'll notice that I already said that D can happen, but only after A. So you can see, therefore, I need a box here, this double box again, and then D can happen. And what happens next? I've got E can happen after B. So there you go, E happens after B. And I've also got that F can happen after B as well. So you can see, it seems reasonable that I have 2 lines coming off that. And then G, well, what can G do? Well, G relies on C, D, and E taking place. So C's got to happen, D has got to happen, and E has got to happen. And immediately I look at this and I think, the way I've drawn it is a bit complicated. So you might be getting your pencil and your rubber out in an exam just to redraw that slightly the other way around. And you'll notice now I've done A, B, and C's in the middle. And now I've only done that so that C, D, and E are all kind of close together. You wouldn't know that before you started, and that's the slightly annoying thing about this. So having done that, I can now say, well, these now go boom into it. There it is. And C, D, and E can now let me do G, and G is there. Now, you usually end up with a little box which says, I've finished now. So here it is. Here's I have now finished. And you'll notice I've completed my activity network. This is the proper activity network. I didn't need any of those dodgy dummy activities that I talked about earlier, which is good because they're a pain in the bum. Otherwise, it's good. Now, what I now need to do is try to find what are called the early event times. And the early event times are the earliest time I could start doing that job without it impinging on other activities. I mean, I can't start D too early until after I've started and finished A. So that matters. So the way I do this is I put a 0 in the first box there. And having done that 0 there, the next question is what can I do after the 0? So you can see the activity A is going to take me 3 days, hours, whatever. So effectively this becomes a 3 there. So I can put that there, that 3. So really all I've done is I've said that 0 plus the 3 equals 3. I can do the same for B. I can say the 0 plus the 4 gives me 4. And that's why that's a 4. Now there's actually 3 activities going into this box here. So I'm going to have to definitely be careful. And the weird thing is I pick the biggest of my 3 answers that I get from doing this. So notice I'm going to go 3 to here plus D, which is 5. That will give me 8. So just bear that in mind, that's an 8. The 0 plus the 6 is 6. Well, that's smaller. And this one's 4 plus that 1 makes 5. So if I was to go this way, I get 5, this way 6, this way 8. I put an 8 in there. And this is me talking about it here. And there's the 8. Okay, so if that's 8, now, well, I've got one more box to do, and I've got the same problem. I've got 2 activities coming into this final node. So I pick the biggest answer. So I do the 4 plus the 6 is 10, or I do the 8 plus the 7 is 15. Now you can see which it's going to be. It's going to be the 15. and therefore the earliest time I filled in all the early event times, and I've got up to 15. Now what we then do, we having done this forward pass as it's called, we do a backward pass, and we look at these what are called the late event times. It's the latest I could do the activity without affecting the efficiency of this process. Now, sometimes it's exactly the same as the early event time. Sometimes there's a difference. It might be I've got a bit of downtime on one of these activities. You don't know until you do it. The very first thing you do is since it was 15 at the end point, you put a 15 for here as well. So that's always the case. If you get a 15 here, 15 there. Okay, and then we work backwards. So we go, well, from here to there, that's only one way to do it. So I can knock off 7. So 15 take away that 7 is 8. And you'll notice there it is. And I can do it this way as well. I can say 15 take away the 6 is 9. Oh, I've got to be a bit careful. I've got 2 numbers coming in. So I've got 8 take away the 1 as well. So again, we're working backwards down here and we're working down here. I've got 2 options. It's 8 to take away 1, which is 7, and 15 take away 6 is 9. Now, the weird thing is, I make this as small as possible. And so for that reason, it's the 7. I think most people would perhaps think 15 take away 9 is 15 take away 6 is 9. You do that, but you don't. You do the smallest one when going backwards. Biggest one when going forwards, if there's more than one. Going backwards, it's the smallest. So now where am I? Well, from 8 up to this D, we can just see it's the 8 take away the 5 is, and notice it's this one here as well. So it's 8 take away 5 is the 3. So that's the 3. But coming into here, I've got 3. So I've got 3 choices to make. I've got 3 take away. That 3 is 0. I've got 8 take away 6 is 2. I've got 7 take away 4 is 3. I pick the smallest. So it's got to be a 0. And this last one will always be the same as the 0, 0. Always happens like that. So the completed network, you'll notice, took 15 hours. 15 hours to do, and you can see it says it there. Now, these are called critical activities. And we to try to find critical activities, we're going to do a little sum. And the sum that we're going to do now is we're going to do this late time. Either side of an activity, you do that 8, take away that 3. So 8 take away 3 is 5. And you'll notice the activity was 5. So because it's the same answer, so I've done the 8 take away 3 is 5. And because it's the same as this 5, that makes it a critical activity. Now, likewise, I can do here. I don't know where all my numbers have gone. Some of my numbers have disappeared. That was from memory a 3, yes, and this was a 7. So if I now do, for instance, for B, I get 7 take away 0, which is 7, but my activity was 4. So that's not a critical activity. This one, the 3 take away 0 is 3, and it is a 3. So yes, yes. This one is 15 take away 8. Notice I do the outer numbers. I do the 15 here, take away the 8, which is 7, and that was a 7. So yes, that's critical activities. So I want to show you one more of these, and then we will be done. So go on to activity 2. Example 2, we've got a similar scenario. So let's just get on and do it straight away. We'll put down a start node. And what we've got over here, we've got 2, 3, and 5, the durations in days for these 3 activities. So straight away, I want to put those down. There we go, 2, 3, and 5 A, B, and C. And I suppose this is my problem, and this is why I highlighted the dummy activities bit to you. Look, D requires A and B to take place. Now, the temptation, I suppose, is to go around here, and then kind of it comes in here, and I just have this box here. But you'll notice it breaks all my rules that I keep on talking about. You're not allowed to have 2 activities for starting and ending in the same place in that way. So rather than do that, let me just rub out that dodgy bit of notation which I've put there. And rather than do that, I want to show you the way we do it instead. And the way we do it instead is to have 2 boxes, one for each. but then they're joined with this dummy activity. Now, this dummy activity is said to have zero duration, so we don't need to worry about it in terms of, it's just a zero. But now we're allowed to draw our D coming off of it, and that's the critical thing. So look out for that. Now, E, it says, is dependent on C, and F is dependent on C as well. So I suppose we're going to have two things coming off of this, and there they are. We've got this box, double box again. E and F are both coming off of it, and G relies on D and E taking place, so they've got to go into the same thing. They start at different places. I don't need a dummy activity here, so they both going into there and there. You see, I've drawn it slightly differently just to tidy it up a bit. And on the face of it, I now just need a G. Well, where does G? G relies on D and E taking place, so it can come out of there. And I just need to finish it off with a final box. Now, this now looks as if it's going the wrong way, so let's draw that again, tidy it up again. And there it is. And I've now completed my activity network. But I've got to now do the numbers, the early start times and the late finish times. So what did I do? Well, I put a 0 in here, if you recall. So there it is. And if you've only got one thing coming out, you can just put those in. So this is a 2. That's an easy. This is a 5. Now this one I've got to be slightly careful. I've got 2 lines coming in. But if you recall, this is of duration 0. So this is a 2, this is a 3. You always put the biggest number going forward. So that's going to be a 3 there. So I'm going to get a 2. I'm going to get a 3, and I'm going to get a 5 there. So what comes into, well, you've got 2 numbers coming into here again. So 3 and 6 makes 9. Keep that in mind. 5 and that 8 makes 13. You can see that's got to be a 13. The bigger number wins. Coming off here then, I suppose I've got a 5 and I've got a 2. That's a 7. But here I've got a 13 and a 4. That sounds to me like 17 is the biggest, and therefore it's 17. I'd now go backwards, try to identify the backward numbers, start with the same number here, so it's a 17 here. I can take off a 4 and I get 13 there. And I can take off a 2 and I get 15 here. But I've got another number coming into here, so I've got to be another activity rather coming into here. So I've got to be careful. I do the 13, take away the 5. The 13 take away the 8, which is 5. What's this one? 17 take away 2. And I've got to do the smallest one going backwards. So I think it's 13 take away 8 is 5. And there it is. So going into here, it's 13. This number here, take away the 6 is 7. There it is. Now, this is of 0 duration, so that one can be 7 straight away. And I suppose now I've just got to go backwards. 7 take away 2 is 5. I've got 7 take away 3 is 4. And I've got 5 take away 5 is 0. So notice, I did say this at the start, this will always be 0. So that one will be 0. So there's our task done. Well, not quite. I've got to find critical activities again. So if you recall, what I did was I did the outside number. 7 take away 0. Is 7, but it's 2, so that doesn't work. 7 take away 0 is 7 again, and it's 3, so that doesn't work. 5 take away 0 is 5, and it was. So I think C is, what else have I got? 13 take away 6. I remember the outer numbers. No, that doesn't give me 13 take away 3, sorry, is 10. That doesn't give me the 6. 13 take away the 5, though, is 8, and that is an 8. So I think that one's a critical activity. And I think this one is as well. Look at this. 17 take away the 13 is 4. Yes, that is. 17 take away 5 is 12, and that's 2. So I think that is my critical activities. C, E, and G. Now, and again, I need to state how the project can be completed. So look, we've done 2 examples. I'm going to save one for the next video, but thank you very much. That is the first attempt at doing critical path analysis for the OCR and Edexcel further maths discrete using activity on the arc. Okay, thank you very much.